Hello, and thank you for tuning in. This research is titled Mapping the Citizen Science Experience, Experiential Pedagogies and Learning Outcomes in a Place-Based Volunteer Program. This work was done by Dr. Nicole Colston and Cheyenne Olson, both from Oklahoma State University. This work also involved Blue Thumb and the Oklahoma Water Resources Center. To start with, what is citizen science, since that is the focus of part of this paper? Citizen science is broadly defined as public participation in scientific research projects. Types of citizen science programs in the field of conservation range from one-time volunteer activities, such as bio-blitzes, to long-term ecological monitoring efforts. The experience a volunteer may have in a citizen science program is broad. Some projects exist completely in a virtual format and allow for crowdsourcing data. Other projects are more based in local community problem-solving experiences. Proponents of citizen science have documented that participation in citizen science has led to many positive outcomes for volunteers, including things like providing enjoyment, developing a sense of community and agency, increased science literacy, and environmental behavioral gains. Nationally, there are an estimated 8,500 volunteers monitoring U.S. water bodies and 26 states that sponsor volunteer monitoring programs. Oklahoma is one such state. In Oklahoma, water quality data is collected by volunteers of Blue Thumb, which is a statewide program that emphasizes stream protection through education and involvement of the community in monitoring local water bodies. Blue Thumb has a variety of programs, from one-time creek walks to long-term stream monitoring, that offer Oklahoma citizens a chance to learn more about water quality across the state and to become activists in their own communities. While evaluation of outcomes from participation in citizen science is often listed as a high priority for practitioners and program coordinators, it actually remains a continued challenge for active and diverse programs such as Blue Thumb. Across the field of citizen science evaluations, many projects have inconsistent methodologies and often rely on creating their own evaluation tools and frameworks. Evaluations may choose to focus on only one or two participant outcomes, or maybe just program objectives, rather than trying to capture the whole of the volunteer experience. Experiential education as a theory of practice explores many related outcomes and engaged learning contexts, such as outdoor education or civic engagement, and has been used to guide the evaluation of citizen science programs. While there are several typologies for participant engagement in citizen science projects, there are few works to date that align the processes of experiential learning with program learning outcomes. Experiential learning as a theory is the theory of learning by doing. It embodies the idea that actively participating in an experience, reflecting on that experience, and applying it leads to active learning and those outcomes that we described. Kolb's cycle, which is diagrammed on the right, consists of 4 steps that conceptualize the process of experiential learning. Kolb's cycle consists of concrete experiences, which are the actual experiences a person has, reflective observation, which is time to reflect on the experience that was had, abstract conceptualization, learning from the reflection and the experience, and finally active experimentation, which is applying what was learned. Citizen science has applied experiential learning to program building and evaluation, but there is room to improve. Experiential learning can be used as a tool for evaluation of sit-side program and practice. By using experiential learning to guide evaluation, citizen science programs may help to really capture that volunteer experience and what is actively gained through the nature of participation and reflection. In an attempt to create a shared metric for citizen science evaluations, a paper was produced in 2018 by Phillips et al., where they created an evolving framework to identify the most common outcomes that were desired across citizen science programs. In this paper, 6 core participant outcomes were identified. These include the different metrics that you see in the figure on the left. Behavior and stewardship is measurable actions that result from engagement in citizen science, such as a participant taking advocate action in their community. Interest is the degree to which individuals assign relevance to a program or a topic. Self-efficacy is the extent to which participants have confidence in their own abilities, either to participate in citizen science or that particular program. Skills of science inquiry are procedural skills like asking questions, collecting, or analyzing data. Motivation is the inclination to participate in the citizen science program or just in science in general. And finally, content knowledge is the knowledge of science or understanding of the specific topic that that citizen science program focuses on. Most citizen science evaluations to date focus on one or two metrics at a time just due to the complicated nature of evaluation. But identifying and evaluating outcomes that are related to the goals of a specific program and identifying where learning occurs to help result in those goals may be the most useful way to approach evaluations. This research attempted to answer 3 questions related to the previous background information. First, what attributes and processes of experiential learning are found within the Blue Thumb programs that are offered? Second, what are the measured and intended participant learning outcomes that Blue Thumb desires for these different activities or programs? And finally, how do Blue Thumb educators employ experiential pedagogies to achieve those learning outcomes? As the first phase of a multi-phase evaluation design, the goal of this research was to map the experiential education processes and learning outcomes of the Blue Thumb program. This phase of the project used a mixed methods explanatory design, where quantitative methods were followed by qualitative methods used to explain or add context to the original findings. First, we conducted a program review of the Blue Thumb using annual reports to identify key program components and previous evaluations. Second, individual surveys were administered to the program director and regional education coordinators of the Blue Thumb program in order to identify learning outcomes and experiential pedagogies. Finally, a focus group with all Blue Thumb educators provided an opportunity to review and formalize the evaluation objectives for the next phase of research, as well as gather qualitative examples of experiential pedagogies and learning outcomes. Kolb's theory of experiential learning guided our data analysis and review of Blue Thumb programs along 3 different dimensions. First, anticipated learning outcomes. Second, the processes of scientific inquiry. And finally, types of participant involvement. Results from the initial survey and the focus group demonstrated that Blue Thumb engages diverse audiences from youth to seniors in a range of different learning contexts from classrooms to land use management. For the volunteer monitoring program, Blue Thumb ranked their top 3 participant outcomes that they desired for future evaluation as behavior and stewardship, motivation, and interest. However, evaluation to date has been limited and focused largely on changes in scientific knowledge following training. Blue Thumb was asked to rank which participant outcomes applied most to each program or activity on a scale of 1 to 5, where 1 did not apply and 5 extremely applied. Activities and programs were then placed into a table based on the level of participant involvement, which was once again determined by survey responses. That data is shown in the figure above. Across the breadth of all Blue Thumb programs and activity, the level of participant involvement in terms of time seemed to influence Blue Thumb perceptions of number and breadth of learning outcomes that were associated with that activity. It's clear that some one-time activities are harder to evaluate. However, some activities hit the sweet spot of experiential learning, like the Enviroscape or the long-term stream monitoring activities. It was evident that activities and programs with higher levels of involvement were expected to have higher relevance to the various participant outcomes across the board, and this may be due to the fact that these activities consisted of more hands-on experiences with reflection and observation over a longer period of time. Blue Thumb programs were placed into an experiential learning map as seen on the left, which aligned each activity or program with the stage of the Kolb cycle that it best reflected and included the level of participant involvement. Examples of experiential pedagogies ranged from passive, so videos and making fish prints, to more active, place-based approaches. There are 3 general types of participant experiences: one-time visits, youth public education events, and volunteer monitoring. Blue Thumb educators identified volunteer monitoring as the priority program, and along an annual timeline of involvement, volunteers in this program engage in the complete Kolb inquiry cycle. Guided by EL theory, our research pilots a method of formative program review that accounts for different program pedagogies, contexts, target audiences, and builds upon a common citizen science evaluation framework as proposed by Phillips et al. 2018. The findings here will be applied to the next phase of evaluation to help guide sampling methodology and inform the creation of a participant survey to assess the learning outcomes of volunteer monitors. Phase 2 will consist of the participant evaluation portion, where surveys will measure behavior and stewardship, interest and motivation. The final phase will attempt to measure a participant's self-efficacy or belief in one's ability as it relates to volunteer data quality. Information from both Phase 2 and 3 will be used to inform Blue Thumb of best practices to achieve their identified learning outcomes and identify any barriers to the program. While evaluation of participant learning outcomes is valuable, applying EL theories helps us to better understand how active learning and scientific inquiry happen in these place-based, data-rich volunteer programs. Indeed, learning by experience in the natural world is the foundation of modern scientific inquiry. Future evaluation of citizen science will benefit from grounding research in established EL theories and pedagogy to answer key questions, such as how can projects be improved by best practices in experiential learning? What psychological and physiological processes take place when doing citizen science? And finally, what EL pedagogies align with different citizen science participant learning outcomes? That concludes what I have to say for this presentation. I thank Dr. Nicole Colston for helping me to put this project together and do the research. If you have any follow-up questions, we will both be available either by email or in the live session. Thank you.